Alright, so welcome to the third video of the unit, and in this unit we're going to look at this class we're going to look at the same stuff we've been looking at the two classics before, except we're going to look at the case where a does not equal 1. So how can we factor quadratics of the form ax squared plus bx plus c where a does not equal 1 by looking for patterns? Alright, so before we start doing anything, let's look at what we've done before. And again, like I said, the past two videos we did stuff that looked like this: x squared plus 11x plus 28. But now we're going to look at stuff that looks more like this: 4x squared plus or minus 9x plus 2. Now notice the big difference is that here x squared is by itself and here x squared is next to a 4. So let's go into a few examples, and then at the end I'll show you pretty much the summary of what we did. Okay, so here's our first example. Factor the expression 4x squared minus x plus 2. Now like before, I want to start off by labeling the parameters just to make sure that I know what I have. This is A. I'm going to call this one B. I'm going to call this one C. So 4 is A, negative 9 is B, and positive 2 is C. Now the first thing we want to do, just like before, is draw the x. So far everything looks the same. Start off with the x. Let me change the colors. Except this is where it's going to get a little funky. Let me change this. Instead of writing 2 on top, what we're actually going to write is 4 times 2. Times 2. Now why did I do that? Well, it's the first times the last goes on top, and just like before, negative 9 goes on the bottom. If you think about it, when we had a 1 instead of the 4, it was still 1 times 2. So actually, we kind of lied to you. It's always going to be the first times the last goes on top. So 4 times positive 2, in this case, let me change a different color, is 8. Negative 9 goes at the bottom. So now, just like before, we want to find two numbers that when you multiply them, you get the top, and when you add them, you get the bottom. Now two numbers that I can think of right now, this is one of those tricky ones, is negative 8 times negative 1, because negative 8 times negative 1, remember, a negative times a negative will give you a positive. In this case it will be a positive 8, and a negative 8 plus a negative 1 is negative 9. So we're done. So far everything looks really familiar. Now here is the really cool part. Here's where the new stuff comes in. Instead of writing the two binomials, instead of writing two parentheses, we're going to use negative 8 and negative 1 to rewrite the middle. So we're going to split the middle in half. Kind of. So let's rewrite the middle. So this is step 2. Actually, step 2 was over here. Beep, 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 beep. Step 3 is split the middle. This is the cool part. So let me change the color. Let's rewrite the middle. 4x squared minus 8x minus 1x plus 2. Now take a second and look at that and see if you can figure out how and why I did that. You might realize that negative 8x minus 1x is still negative 9x, which is pretty cool. But anyways, this is the step. This is the main step, splitting the middle. Now here's where the next step comes in. Now that we split the middle, we need to find the greatest common factor for each of the groups. So what I mean by each of the groups is that these two are going to be one group, and these two are going to be one group. I'll write this over here. 4x squared minus 8x. What goes into both of those? Well, I already can see that you can go take a 4x out. You're going to be left with x minus 2. And over here, you can take a negative 1 out. So let me just rewrite it. And you'll be left with minus 1 times x minus 2. So here's the cool part again. So in this case, you can take out a 4x from the first group and a negative 1 from the second group, and you see the patterns that will help you determine what you need to factor out. So let me scoot this up a little bit. Now, Here is, again, please be looking at the notes while we're watching this because it's going to get a little intricate, it's going to get a little complicated. Let me do this, change the color again. We have 4x right here and a -1 right here, and we have x minus 2 and an x minus 2 over here. Here is the last and final step. Step 4, bum, bum, bum. Gets a little tricky, but let me change the color real quick. What we're going to be left with is 4x minus 1 and x minus 2. Let me underline these. Does everyone see how I got that? Took that 4x and took that minus 1, put it together, and got those x minus 2 and put them together right there. And that is actually our final answer. Now I know this was really confusing, so I'm going to go through another example in a little bit. But first, here's our fun fact of the day. Did you know that the Hawaiian alphabet only has 12 letters, and they are shown to the left on the palm tree? They are A, E, H, I, K, L, M, N, O, P, U, W. So go on and see if you can find any other words. Let me know. Some of them are really cool. Some of them are kind of weird, and some of them are really hard to pronounce. Okay, so here's our second example. I'm going to go through this one a little bit quicker. Let's start off with the X. Boom, boom. If you remember what goes on top, it's the first times the last. So in this case, 5 times 20, which is 100. What goes on the bottom? The middle number, -20. What two numbers, when you multiply them, equal 100, and when you add them, equals -20? This is a tricky one, but I'm going to go with -10 and -10. -10 times -10 is positive 100, so that gets us on top. And then -10 plus -10 is -20, so that's how we get that. Oop, that's supposed to be a times sign. Now let's split the middle. That's the cool part. Split the middle. So let's get this and rewrite that. Let's rewrite the entire thing. So we're going to get 5p squared minus 20p plus 20 is the same thing as 5p squared minus 10p minus 10p plus 20. Now let's look at our first group. Let me actually write it right now in different colors. So I'm going to do this one, 5p squared minus 10p. I'm going to try to explain it a little bit differently than last time. Minus 10p plus 20. Out of this first group right here, what can we take out? Let's take out a 5p. 5p, it's like reverse distribution. So this number is going to be p, and this number right here is going to be -2. And over here, second group, the blue group, let's take out a -10. So minus 10. This is going to be stay as p, and this is going to be -2. Notice any patterns? Because I see some. Here we have 1, 2, 1, 2. We have two of the same numbers. We have p minus 2. Oops, sorry about that. P minus 2 and p minus 2. So then we can rewrite this as 5p minus 10 and p minus 2. Let me underline these so that you know where I got these from. 5p minus 10 is the 5p minus 10. P minus 2 is the p minus 2 that is common in both of them. So here's our final answer. So now we're done. I'm going to take the last slide to kind of review everything that we did to refresh ourselves, and then after that you can start the classwork, or if you feel comfortable right now, go ahead and start the classwork. Alright, so step 1, let me look at an example. I lost my example. Okay. Step 1 is always write the skeleton. Do this. I'm going to use, in this example, 3x squared plus 10x minus 8. Remember that in this case, in the top you would have -8 times -3, which is -24. On the bottom you'd have 10. And you figure out the numbers. Find the two factors. Step 2 would be, in this case, you write everything, 12 and -2. Step 3 is split the middle. So you would rewrite the whole expression as 3x squared plus 12x minus 2x minus 8. Step 4 would be find the greatest common factor of both groups. Again, this is group 1 and this is group 2. So the first group I would say, let me start changing color, 3x times x plus 4. The second group I would do negative 2 times x plus 4. And then rewrite and simplify. So we have one group right here, one group right here, and then the second one. So we end up with 3x minus 2 and x plus 4. Now here's your summary of this thing. It's very procedure and groups. We're going to try to go over why this makes sense, but for now it's just a procedure, so good luck. Start the classwork and let me know if you have any questions.